Hello and thanks for joining. I'm Les Key, the Sales Engineering Manager for Starboard Storage Systems, and in the next few minutes I'm going to walk you through the AC72 dashboard, which is our interface for monitoring, managing, provisioning the AC72 storage solution. Before we dive into the different features and what's contained herein, I want to take a moment and just glance at what you're seeing in front of you now. And what we're seeing is, again, an all-inclusive presentation that's built to be easy to use for the generalist of IT to manage, not necessarily the specialist of IT. It's comprised of a hierarchical structure that goes from left to right, hardware to logical, and also some pretty key indicators on the screen itself. On the very top, there are four icons: a house, a rotating arrow set, a lightning bolt, and a power button, which is just that. So the house is a way for us to come back to this home screen regardless of where we happen to be in the interface. So it doesn't matter if you're 1 layer deep, 10 layers deep, click this button, you're back to here. Pretty simple. The refresh button, there for those who connect over wide areas, multi-layers, has some latencies once in a while, going to get a shattered screen. Hey, if you're connected locally, it doesn't matter. But we all work from home, and this is a chance to get a refresh if it ever needs to happen. The lightning bolt next to it, a restart button. So not to be done unless we're talking to support, but it's here. And next to that, a power button. The last two give appropriate warnings. So it isn't just a click and do, it's a click and are you sure you want to do this a couple of times, and then we do it. So with those, I also will point out there are a series of green dots and blue plus marks in front of you. Those green dots are health indicators for different categories. Again, left to right, physical to logical, the connected storage, the storage system, the storage pool, the volumes, and the connectivity options. These are all healthy at this point in time, operating according to as we expect them to be operating. For those with with the blue plus mark, that means we can add to it here. It will kick off a storage app or a wizard, if you will, to let us walk through in a very programmed manner and add. So it's built to be easy, built to be systemic, and built to fill in the blanks if you forget something. It's a smart system. So if we also can see at the bottom the IP address we're connected to. We can see the active and the standby the storage nodes. It is a highly available system. And we can see a series of graphs indicating capacities. This particular system has 12 terabytes of active space, and we can see we have used hardly any of that at all. We see the storage pool itself is 12 terabytes, a little bit overhead assigned to it. And then we move down the volumes that are on the system, et cetera, et cetera. I will say before I drill down into the storage side, everything here is thinly provisioned. So when you create an allocation, the consumption of that is only what is used, not what you've asked for. So with those few points on the table, let's take a look at the different features. Let's start at the hardware level, shall we? The connected storage. I'll click the health arrow and we'll see that we have an inventory of the physical drives that are connected. In this particular case, there are 12 1 terabyte drives that we use in our capacity, and there are 3 80 gigabyte SSDs in this particular system. Every time we use the interface, it reflects exactly what's in it. This is a demonstration system. Our shipping systems will have larger SSDs and larger disk drives, but it really doesn't matter. It all works the same. I'll click the home button to reach back to the front screen, and we'll click on the storage system. And this is an adaptive view of what is actually installed and what we're connected to. In this case, we have a head unit, and that head unit has 16 drive bays. 15 of those drive bays are consumed. The left 3 are SSDs. We'll talk about that in just a moment. The right 12 are spinning drives. In our case, those 12 spinning drives happen to be 1 terabyte nearline disks. So, nearline SAS. Everything on the system is SAS based, whether we're using 15,000 RPM enterprise class SAS or we're using the 7.2K RPM nearline SAS, it's all SAS. And it's 6 gig SAS, so it's as fast as you can get in the industry for back channel connection. This display shows our disk pool 2 different ways, physically and logically. So the logical definition, the inventory list, if I click on a drive here, it will highlight that drive accordingly on the bay. If I click on a drive on the bay, it will highlight it accordingly in the inventory list, as you can see. By either one of these, I can highlight that drive and make it beacon on the front. Notice identify disk button here and the identify disk button here. It's the same. So made to be easy, made to be visual, made to be not a headache. The back view button does just that. Takes us to the back of the system. And this is where we see connectivity options that has been assigned to the system installed. It's adaptive. This particular system has, as do all systems, has two fixed 1 gigabit ports, has a KVM attachment port, has a built-in 6 gigabit expansion port. This 6 gigabit port, along with this top slot, which can have an additional 2 ports, enable a single AC72 system to address either 5 additional 45 bay expansion chassis or 6 16 bay expansion chassis. So a single AC72 can see 237 spindles slots if we use the 45 drive option, or it can see 108 spindle slots if you use the 16 bay option. And past the head unit, which has to be all the same kind of drive, the rest of the expansion chassis can be mix and match. We can have a mix of 15Ks and 7.2Ks to meet the needs of your data center, and you can expand that well non-disruptively. The center part, where I'm pointing to now, is our connectivity options set, and these 2 slots can be comprised of any combination of a 4-port 1 gig Ethernet interface, a 2-port 10 gig Ethernet interface, or a 2-port 8 gig fiber channel interface. Mix and match. You can put all 3 online. We could have 1 gig, 10 gig, and 8 gig fiber online in a single AC72 at one time, if you so desire. The protocol set is all built into the intelligence of the operating system. It's just a matter of whether or not you've elected to use those adapter cards. In this particular system, we've elected to use, in our test environment, again, the built-in 1 gig ports. We have the optional 4 1 gig ports. And in our case, for our test environment, we have a single port fiber channel card. Our production systems will be using dual ports. Dual power supplies, they can run on one, and it is a green rated machine. That's nice to know. And again, expandable at will. So there are 2 storage nodes here. They are mirrors of each other as far as their options that have been installed, because they do watch each other. It's a highly available system. It can run on one just fine. And it will be on one active and on the other one standby at all times. In this case, the node A, left side is the active node. Node B is the standby node. If something happens on A, it will transition to B. Your load will stay online. Your service will stay online. And most importantly, your end user community stays online. Going back home, we can take a look now at the storage pool. And the storage pool is the heart and soul of the AC72. I'll click on the green arrow. That will take us into the definition set, what it happens to be here. I said I'd come back and talk about the SSDs a little earlier. I want to talk about those now, because those 3 SSDs that are contained within every AC72 and designed within each AC72 serve a critical need. We use those for our write caching. There are 2 mirrored SSDs we use for write caching, and there is another SSD we use for cache spillover and for read acceleration. By incorporating algorithms and applying them to these SSDs, we're able to take a nearline 7.2K SAS spindle and deliver a speed of 140 to 155 IOPS per spindle, which is near the speed of a 15,000 RPM SAS spindle that's been unbiased. It's raw out of the box, which really means that because of this technology, we can give you more space at lesser cost with an AC72. The other part of the SSD set is that it provides us our acceleration layer is that it's made to ingest true mixed workloads, whether it's block data, file data, whether it comes from Ethernet, whether it's NFS, whether it's CIFS, whether it's iSCSI or fiber channel, we don't care. It all ingests at the high rate of speed and is then promoted to the appropriate level of disk as you've defined based on the application's needs. So let's talk about that, how we look at the physical drives themselves. So drives are really in two classes. They're either nearline or they're enterprise, right? The nearlines are 7.2, the enterprise are 15K. We're all talking SAS here. We're all talking 6 gig connectivity. So we've got the fastest interconnect we can have. It's just a matter now of which set of disks you want to use. We'll aggregate those disks by their class into a group, and that group will be a pool. So, and that pool can grow, by the way. It isn't fixed once you establish it. It's not a hard bound. The hard bound is 237 disk slots per AC72. That's the hard bind. Beyond that, you have flexibility of growth. But that pool is where data lives. And that is the only place data lives, is on the pool and of the pool. It's not bound by a RAID set, it's not, or a RAID type, or a volume boundary or anything else. It is a set of disks that constitutes space. In this case, in the example we're looking at, our space is 12 terabytes. That's what we have to work with, 12 terabytes. It's not been formatted by RAID. It hasn't been altered in any way, shape, or form. It's 12 terabytes. So how do we talk about this? What do you mean? How can this be? It's like this because we're not using the traditional RAID methodology. We're using a soft RAID laydown methodology. We're going to lay data onto the disk based on a rule set, and we're going to lay it down in a rule set we're going to call a layout. And that's exactly what these layouts are. They are RAID emulating rule set definitions that onto which we'll attach volumes logically, and as data passes from the host to this logical thing called a volume to this rule set that doesn't take up any space called a layout, it hits the pool in some type of what you would consider to be a data protection scheme similar to RAID. And we're going to use either a parity-based RAID 50 or a mirror-based RAID 1. But that's not the only choices you have. And just so you know, a layout has more options. As a matter of fact, a layout has options of being, hey, what style do you want? Let's say a RAID 50, into which case you'd have data drives and a parity drive. That's what a parity-based RAID does. It says, how big a chunk size do you want? And this is where you get a chance to make a definition or a rule that really is commensurate to the application you want to connect to. You may want a small block write or a wide block write. You get a chance to choose that right here. How many drives do you want to incorporate into this set, in this logical laydown set? So if we take it on a say a 5 drive set or an 11 drive set, we have different usage factors and different speed factors. That's okay because we're going to make our auto tiering level capture the data, which is again a part of the SSD logic. It's going to capture the data at high rate of speed, bounce it out to the servers, and then push it down where you want it to live. You don't want long-term archive data on your faster layouts. You want it on a depth layout. It just makes sense. You get a chance to choose that. And also a part of that would be your spares. How many spare stripes do you want? And the spare stripes is where we gain rebuildability of a failed disk. So our rebuild times are fast. They're not traditionally a one drive out has to be fully rebuilt before you go on. A drive failure is immediately reconstituted across the surviving drives of the pool onto the spare stripes. So a rebuild is quick. When the physical drive is replaced, it is reconstituted from those spare stripes. So not only is the impact of a failed drive minimized, the recovery time at the physical layer is minimized based on the mechanisms in place with the AC72. Okay, so here we have the pool. we have this layout definition that emulates RAID. It's not physical RAID, it's emulated RAID, soft laydown. Then we have volumes. A volume to an AC72 is nothing more than a high watermark of definition. Doesn't bind disks, it doesn't subdivide the pool. It's just, hey, I've got something I want to name with a name, and it's going to be so big, and I'm going to use that as my logical demarcation to a host. That's about as far as it gets. It's extensible, it's modifiable, and again, it's a rule set. So what this really means is that from the pool to the connection, you have 2 degrees of abstraction where you still retain the identity of the pool in its pure state. And all we're going to do is set rules to how data lives on that pool. That's it. So to build a volume, there's 2 ways we can do it. We can click on a layout and right-click on that point and get the option to, hey, create a volume. To which case we get a dialog that'll ask the things you expect in life. What do you want to call it? How big do you want it to be? Or we can go to the simpler way in life and invoke our storage apps. And storage apps are pre-sequenced question-answer sets that take you through step-by-step of a function you want to perform on the AC72. Let's build a volume. Well, you'll see kind of the same thing, a little different format, same kind of questions, right? Right up front, say, what layout do you want to use? Well, in this case, we have 2 choices. A mirror-style layout, RAID 1. It also includes a spare, by the way, inside of it, by choice on this particular layout. Or we have a parity base. We'll use a parity base. What do you want to call it? I'm going to get my initials. And how big do you want to make it? Let's make it 500 gig. Now, we can define it in integer value, as you can see up here. It can be either power 2 or power 10. I'll just use the traditional way. And I'll say create. Now, what's going to be magic when I click the word create on this panel is that it's going to build the volume. Everything we do on an AC72 as far as provisioning is done with thin provisioning. Therefore, all I've done is put a marker down. It takes a little bit of space for the header information, but outside of that, there's no pre-reservation. It's a high watermark. That gets reported back to the server eventually when we build the connection paths, and that server thinks it has a volume of a certain size. In reality, it is just nothing more than a set of pointers that go from the connection to the ingest down through the logical volume point, high water pointer to the layout, and lands on the pool. The pool is the only place data lives. So here we have it. I clicked create. The volume was made. These storage apps take it to the next level higher, and they'll say what is the next logical progression based on what the individual asks me to do. In the case of build a volume, you want to make another volume. You want to make this volume into something you want to use, and you get that option right here. In our case, I'm going to say finish, because there's a few things I really want to show you about this volume. First of all, it is thinly provisioned. It has a capacity, high watermark. How much have I used? I haven't used anything yet, so it's just there. It's just a flag on the system. If I right-click on this, though, I'll see some other options appear. And one of those options gives a chance to, hey, I can disable it. Which means I can leave the data there. I can just turn it away from being written to ever again for right now. Maybe I want to archive or park data. Okay, I'll disable the volume. I'll park it. The other options are to snapshot the volume, which simply means I'm going to draw a line in the sand based on the data that happens to be there, put an insulated barrier between that data and what comes next, and start collecting new data blocks. So we have a way of having a zero-based snapshot inside the same container and inside the general pool of data of this particular class of drive. We can create a snapshot either ad hoc, immediately, or I can do it on a schedule. So if we do a scheduled snapshot, it's going to give us the options you might expect. It's going to say how many you want to keep. I'll leave it at 10 to the default. And when you want to do this, okay, I want to start this, let's put it at 12:55. And then what's your retention policy going to be? How long do you want to do it? I'll leave it like it is, say select, say save, and it puts it into motion. In just a few moments, we'll have as soon as the clock changes, we'll have a snapshot created on the system, and you'll see the first snapshot appear. And when that snapshot does appear, I'll get a chance to show you a couple of more things about it. In the meantime, I'm going to look at this volume again, right-click on it, and you'll notice down at the bottom there's an option that says resize. And yes, we can change the size of these volumes, increase them at will. So I can go from 500 to 600 by the click of a button and say go right ahead and do it. And we'll just go ahead and do it right now. And as you might expect, hey, there's the next logical progression. We want to do another one. Now we'll just finish right now. So that's all there is to actually creating a volume and resizing a volume. In just a moment, we're going to get a snapshot appearing here. If I want to make more volumes, I do just that. If I want to make more layouts, I do just that. So again, the AC72 is architected for the mixed workload environment. There's nothing more mixed workload than a virtualized server. Because in a virtualized server, you have a stack and you're emulating X number of physical machines. What comes out the back of a virtualized host is scrambled eggs of data. The AC72 is pre-architected to manage that flow and put it where you need it. So keep that in mind. Mixed workloads is a trend of the future. Snapshot's been made. It's here. If I right-click on the snapshot, we can see some other options become available to us. We can say it can be removed, of course, as you would expect it. If you remove a snapshot, the blocks are promoted or demoted accordingly. We can promote a snapshot, which implies that I'm going to make this into the active volume, this current layer at a point in time. Something's happened to the current write pool. Because remember, a snapshot is a zero-base entity. At the time of snapshot, you're drawing a line in the sand. You're insulating the data blocks as they were, and you're collecting new blocks going forward. If you're going to promote a snapshot, something's happened in that active collection process. Those blocks are no good anymore. You want to go back to a prior generation, make that the active write pool. That's promote. Other folks call it rollback. And we have the chance to clone a snapshot. Cloning a snapshot gives us the option to take a point in time and make that into a logical functioning entity. So upon cloning, I can now mount this, recover a file from it. I can use it as a test bed and do whatever I want to do with this. And you'll also notice the fact that it has a logical state. Therefore, it can be operated upon just as a standard volume can be. And yes, we can create snapshots of these clone snapshots. And the way we go on and on and on and on and on. And it does not circumvent the snapshot process, because you notice the snapshot's still alive and well. We just made a set of pointers and made this look like an active volume header at the time. I'll go ahead and remove this particular clone, just so you can see the fact that removing gives you a warning. That's always a good thing to have a warning when you're going to take a volume away. And in a moment, it will act upon that, and it'll be gone. So the snapshot's still in play, volume's still in play, still attached to the active host if it had been attached, and still pushing data. All well and done. Simple as that. Again, the AC72 designed for the generalist, not necessarily for the specialist. It's your choice. So that's volumes, snapshots, extensions, add-ons, etc. So let's go back home and see what we can do from here. So we created a volume. At this point in time, I'd like to create a connection to that volume, and I'm going to use the iSCSI protocol to make that happen. Keep in mind, iSCSI, Fiber Channel, NFS, and CIFS are all active all the time. It's a matter of the interface of the system. So if Ethernet's active, iSCSI, NFS, and CIFS are possibilities. If a Fiber Channel card is installed, then Fiber Channel is a possibility. So it's a very flexible, durable system. Also, it can be changed. When you buy it in format number 1, doesn't mean that you have to throw it away to have format number 2. You change it. Okay, so it's just a matter of the optional adapters to it. To build an iSCSI LUN, I can click the blue button, as we talked earlier, or I can go up to Storage Apps and say iSCSI LUNs. They both do exactly the same thing. The blue button is nothing more than a shortcut into Storage Apps, that feature. I'll click it. Let's see what happens. Create an iSCSI LUN. It's going to ask me some questions, right? It's going to say existing target. You're going to pin data to it, or is this something brand new? Let's make it brand new. First thing, what do you want to call it? It gives us an internal name for it. Not very exciting, so let's just call it something else. Do I want to use CHAP, yes or no? And not this time. And what virtual IP address do you want to use? Well, since we have so many connectivity options, and 1 gig on the fixed, we have the 4x1 gig add-in card, 10 gig, some variety thereof. We also build virtual IPs over the subnets we define as we build these networks. That's so we have portability between the 2 storage nodes. Right? So we select which path will be addressing this target through the virtual IP address. And in this case, I'll just go ahead and pick this one. Say next. The next question asks is what's going to be the server's identity, the iSCSI qualified name of the initiator. Let's just put one in. iqn.host1.server.com. Hit the add button. This is normally what you would copy and paste from your host discovery panel in Windows or from the initiator value in Linux into this value, but I just made this one up just so you can see how easy it's going to be. And also notice as I'm doing this, our status indicators on the dashboard have went from green to amber. Something's going on. Something's incomplete. And yes, it is. We are in the process of building an iSCSI LUN. It's letting us know if I would cancel this process right now, they would stay amber, letting us know something wasn't complete. So we're going to find those will go back to green just momentarily. So I've identified the IQN, iSCSI qualified name. We go to next. Next is what volume do I want to use? Well, I just built this volume. Let's go ahead and use that one. I'll say add. This number is incrementable because we can have multiple volumes to a single target. So that's why it's like that. Next, and the last thing is turn it on. So in 4 easy steps, I have gone from nothing to something for an iSCSI LUN. Again, it's built to be simple. Hit the finish button, and you'll notice the indicators went from amber back to green. Everything's good, and that particular iSCSI LUN is online, ready to be acquired by the host, formatted, and put into service. Let's look at an NFS volume. We all know NFS is becoming more popular on a virtualized system, so let's see about making NFS. Maybe it's tougher. Let's find out. I'll click the blue button. Hey, here we go. There's a storage app popping up. This programmatic sequence of events. Already figured out. Let's say next. Yep, I want to do it. What file system are we going to use? Well, we're going to use, I don't have a volume. Let's create one. And since I don't have a volume, you'll notice there's no eligible volumes appearing. Well, one of the things you'll find about our storage apps is that they take care of that. If it wasn't for the intuitiveness, we'd have to go back and start over again, right? Make a volume come back to this point, but there's a new button on the lower right-hand side here. I'll click new. And what you're going to find is going to flip us right into the Create Volume Wizard, our storage app. I'm going to tell it where I want to go. I'll make an NFS volume, and I'll give it a size. I'll say Create. You'll see the familiar panel of what do you want to do next come up. In this case, I'm going to finish when it appears and creates that volume, and it's going to take me right back to where I started from, which is right here asking for a volume. And there's the one we just created. I'll say next. I've selected it. It'll just mark it for us. I could change these labels. I'm going to leave them like they are for right now. And so you notice the left side there's a progress map. You can see where you are in the sequence. Yep, we're happy we've built the file system on already. We're going to select a folder down to start putting data into. So we got a root level. So I'm going to assign a folder under the root level. Next, here's the permissions set. Now it's asking for what hosts are allowed to touch it. So here's a case in point. I can put in basically a DNS entry, an IP address, or I can say anybody can touch it, and that's what I'm going to do for right now. So anybody can have this. I'm going to enable write to that volume. Add it. We're going to say what IP address we want to use. We'll use this one, the virtual IP. Enable the mount point. Say next. And we're done. Finished. So again, a few pre-programmed, well-defined, orchestrated steps, and we've done an NFS volume just as we did an iSCSI volume, just as we could do a fiber channel, just as we could do a CIFS. They all follow the same pattern. Pure orchestration, the ability to reach out and make up for anything we forgot and keep it right on going. So again, it's simple to operate. So we've gone from the physical side. We've looked at the hardware. We've seen the storage pool. The provisioning subset. Also notice there's replication as an option. It's built in. So it's already here. And we have the logical side, which is, of course, the connectivity to the host. Also, built into an AC72, we have a set of analytics for key measurements. So they appear right here to real time. It captures for an hour. It also keeps a 24-hour window and a 7-day window for quick observation to see if there's been trends established in the last week or not. Along with that, we have the ability to report from the AC72, and that's done through one of three ways. It can be done through SMTP, email. It can be done through SNMP, trap sets. And we also have a built-in call home feature. It all comes with the system. Everything you've seen and we've talked about and we'll talk about in this conversation is built in. There's no added charge for anything. When you purchase an AC72, you get everything. What you also get is a declining cost as you add expansion chassis. So in a lot of systems, there's a license to use charge or some kind of a right to use charge for adding disks that doesn't exist with Starboard storage and AC72. The burden is carried in the head unit. Everything else is added to that. It's just declining costs through time. So our cost per terabyte is sub $1,000. It gets to be pretty aggressive. On the so we mentioned the fact we have reporting on the firmware side of the house. We do have the ability to update firmware on the run. So you don't have to shut down your servers. You don't have to quiesce items. You just do the job. So firmware updates can be acquired either from the system itself, if you want to activate the FTP settings, or they can be downloaded to an attached server or a workstation and then imported into the system, your choice. Either way, it's an update failover process that keeps you online and functioning as this is taking place. So with an AC72, what we're giving you is true dynamics. We have the acceleration layer with the SSDs and also incorporate the auto tiering mode, right? You don't have to have complex algorithms. It's always on, always working for you. It's built to handle mixed workloads. You don't have to think about what's coming into the system. It takes care of it for you. The expand on the fly, a fully enabled feature set, reporting, monitoring, and rolling updates on firmware all come in the package. I hope you would take away some valuable knowledge these few minutes we spent together. If you have more information, please reach out to www.starboardstorage.com or call your local representative. Thank you for your time.